Dear students, in previous class we were discussing about the Cauchy sequence. So we see that the properties of Cauchy sequences, also sequence minus 1 power n is not a Cauchy sequence, but sequence 1 by n is a Cauchy sequence, and so on. Now, suppose x equals xn, let x equals, consider a lemma, let x equals sequence xn be a convergent sequence of convergent sequence. It's a convergent sequence of real numbers. Then sequence xn is a Cauchy sequence. That is, every convergent sequence is Cauchy. Every convergent sequence of real numbers is Cauchy sequence. Every convergent sequence of real numbers is a Cauchy sequence. How to prove this one? So for let x equals sequence xn be a convergent sequence of real numbers. Xn convergent means let secant limit xn, let limit n goes to infinity or limit xn equals x. That is, x sequence xn converges to x. It is given, this is the given argument. Secant xn is a convergent sequence of real numbers. Let sequence xn converges to x. Now, so secant xn converges to x means that is means for all epsilon is positive, there exists a natural number k such that modulus of xn minus x strictly less than some epsilon by 2 for all n greater than or equals k. Clear? Now consider for the Cauchy sequences, now consider modulus of xn minus xn. So this modulus of xn minus xn can be rearranged as it is modulus of xn minus x plus x minus x. Okay. So which is less than or equals by the property of modulus, it is mod xn minus x plus mod x minus xm. Mod x minus xm is nothing but mod xm minus x. So according to this argument, it is strictly less than epsilon by 2 plus epsilon by 2 when you can replace n by m equals epsilon. That is, modulus of xn minus xm strictly less than epsilon for all n comma m greater than or equals some k. Agreed, where k is a natural number. So mod xn minus xm strictly less than epsilon for all n m greater than or equals k means this is nothing but the definition of Cauchy, that implies xn is a Cauchy sequence. So every convergent sequence of real numbers is Cauchy. Every convergent sequence of real numbers is Cauchy. Okay, this is an important argument regarding the Cauchy sequences. If there is a convergent sequence of real numbers, then immediately we can conclude that that sequence is a Cauchy sequence. Clear? Now we are going to another important result, that is Cauchy sequence of real numbers is bounded. Every Cauchy sequence is bounded. Cauchy sequence is bounded. We know that convergent sequence is Cauchy. And the second result of next argument is every Cauchy sequence of real numbers is bounded. How to prove this one? Cauchy sequence of real number. How to prove this Cauchy sequence of real numbers is bounded? First we consider a Cauchy sequence of real numbers. Suppose let secant xn be a Cauchy sequence of real numbers. Means for let x equals xn be a Cauchy sequence of real numbers, which is Cauchy. X equals xn is Cauchy means for all epsilon is positive, there exists k for n, there exists a natural number k such that modulus of xn minus xm strictly less than epsilon for all n comma m greater than or equals this k. Okay, so this is the definition of Cauchy sequence. So in particular, choose epsilon equals 1. Okay, so that means modulus of xn minus xm strictly less than 1 for all n m greater than or equals k fall in n. K is a natural number. Enough. But we know that modulus of a minus b, it is less than or equals mod a minus mod b. Okay, so modulus of a minus b less than or equals modulus of mod a minus mod b less than or equals modulus of a minus b. Okay, modulus of a minus modulus of b, mod a minus mod b less than or equals modulus of a minus b. So from here we have mod xn minus mod xm less than or equals modulus of xn minus xm. Agreed? That means mod xn minus mod xm strictly less than 1 for all n comma m greater than or equals k. Why? Because mod xn minus xm strictly less than 1. That is from the Cauchy characters of sequence x. Agreed? So mod xn minus mod xm less than 1. That means modulus of xn strictly less than 1 plus mod xm for all n comma m greater than or equals k. Okay, so you can choose some m. M is a large real number, sufficiently large real number, where m equals this maximum of k1, maximum of mod k1, mod k2, etc., or mod x1, mod x2. Mod xm. So it is mod x1, mod x2, mod x3, etc., 1 plus mod xm. Okay, so m equals maximum of mod x1, mod x2, etc., 1 plus mod xm, or it can be again rearranged as this m is maximum of mod x1, mod x2, mod x3, etc., mod xk plus 1, 1 plus mod xk. Again this can be rearranged as mod, for more clear, mod xk plus 1, 1 plus mod xk. M is chosen in this way. What is m? M is a sufficiently large real number. This m is chosen this way. M is maximum of mod x1, mod x2, mod x3, etc., mod xk plus 1, 1 plus mod xk. So that is, but here mod xn less than 1 plus mod xm for all m greater than or equals k. So in particular, here this mod xn strictly less than 1 plus mod xk for all n greater than or equals k. Okay, but we can choose m equals maximum mod x1, mod x2, mod x3, etc., this one. So from here clearly we have mod xn strictly less than m for all n greater than or equals k. That means secant xn is a bounded sequence. It is given secant xn is a Cauchy sequence. That is by the definition of Cauchy. For all epsilon is positive, mod xn minus xm strictly less than epsilon. Here we choose epsilon is 1, that's only for the sake of argument, for all n comma m greater than or equals k. But we know that mod xn minus xm less than or equals mod xn minus xm. So it is less than mod xn minus mod xm less than 1. That means mod xn less than 1 plus mod xm for all n m greater than or equals k. In particular, mod xn less than 1 plus mod xk. Okay. Then you can choose a sufficiently large real number m, such as m is the maximum of these mod xi's. Means mod x1, mod x2, mod x3, etc., mod xk plus 1 and 1 plus mod xk. So it is mod xn strictly less than 1 plus mod xk for all n greater than or equals k. That means but 1 plus the maximum value of this one is m. Therefore mod xn strictly less than m for all n greater than or equals k. That means secant xn is a bounded sequence. Means Cauchy sequence, every Cauchy sequence of real numbers is bounded. Every Cauchy sequence of real numbers is bounded. Every convergent sequence of real numbers is Cauchy, and every Cauchy sequence of real numbers is bounded. Therefore, every convergent sequence of real numbers is bounded. Listen, every convergent sequence of real numbers is Cauchy, and every Cauchy sequence of real numbers is bounded. Therefore, every convergent sequence of real numbers is also bounded. Agree? Every convergent sequence of real numbers is bounded. Now listen, Cauchy sequence of real numbers is bounded. What about its reverse inclusion? Is every bounded sequence is a Cauchy sequence? Bounded sequences, bounded sequences implies a Cauchy sequence. That's our question. We already see that Cauchy sequence of real numbers is bounded. Now, what about this reverse inclusion? Can you say that the bounded sequence of real numbers is Cauchy? So consider, let x equals, or sequence xn equals minus 1 power n. We know that sequence xn or minus 1 power n is a bounded sequence. It is bounded. By models, what is mod xn? Mod xn strictly less than sum 2. Okay, minus 1, what is sequence xn? It is 1, minus 1, 1, minus 1, 1, etc. and so on. So mod xn strictly less than 2. So clearly, the sequence xn is, then sequence xn is a bounded sequence. This is a bounded sequence. But we already see that secant minus 1 power n is not a Cauchy. It is not a Cauchy sequence. This is we already proved. Sequence minus 1 power n is not a Cauchy sequence. Why? Because we know that here suppose some xn plus 2 or xn plus 1 minus xn. Xn plus 1 minus xn is some 2. If we choose epsilon is 1 by 2, then we already see that this is already a proved result. Minus 1 power n is not a Cauchy sequence. Minus 1 power n is a bounded sequence, but minus 1 power n is not a Cauchy sequence. Therefore, bounded sequence of real numbers need not be Cauchy. It need not be a Cauchy sequence. Sequence of every Cauchy sequence of real numbers is bounded, but bounded sequence of real numbers need not be Cauchy. That is proved by using this example. We know that sequence minus 1 power n is a bounded sequence of real numbers, but we already proved that it is not a Cauchy sequence. Okay.